Okay, so the function f of x equal to kx cubed minus 8x squared minus x plus 3k plus 1 has a 0 when x is equal to 2. And it's asking graph f of x and determine all the zeros, and then we rewrite f of x in factored form. So what would our first step be in defining our k value? So remember that function has a 0 when x is equal to 2.
Like, 2 and 0.
Okay, so our points is going to be 2, 0. So we're going to sub in 2 for x and 0 for y. We have 0 is equal to k times 2 cubed minus 8 times 2 squared minus 2 plus 3k plus 1. We then have to simplify the exponents, so we get 8x, or 8k, sorry, minus 32 minus 2 plus 3k plus 1. And when we collect all the like terms, what does it simplify to?
11k plus 3 or minus 33.
11k minus 33. All right, and then we have to isolate for k. So we move the negative 33 over. So we get 33 is equal to 11k. And then we have to divide both sides by 11. So what does k equal? 3. Okay, but there is more to the question. Okay, so now that we know what our k is, we need to be able to factor out this whole polynomial expression over here. So now that we're given k, how are we going to turn this into an actual polynomial equation? What are we going to do with the k value we found? We're going to sub it back into the equation. So remember, we had k is equal to 3. So now we're going to sub in 3 for k. So we're going to get 3x cubed minus 8x squared minus x plus 3 times 3 plus 1, which just simplifies to 3x cubed minus 8x squared minus x plus 10. So this is what our actual polynomial function is, now that we know what k is. Okay? So now what we have to do is we need to factor this whole expression so that we can actually graph it. What did the question state? What was one of our factors or zeros?
When x is equal to 2.
Yeah. So what would our next step be into factoring this equation? What are we going to do with that, with knowing that our factor is a 2? We learned this 2 lessons ago.
Divide?
Divide? Yep. Are we going to use synthetic or long division?
Synthetic.
Synthetic, because we have that factor. 2. We're going to write down our coefficients. So we have 3, negative 8, negative 1, and positive 10. So as usual, the first one is dropped. Okay. What is 3 times 2? 6. Negative 8 plus 6 gives us negative 2. And then we do negative 2 times positive 2, which gives us negative 4. And then we add those two together, which give us, and then we get 10 plus negative 10, which gives us 0. Okay? So now we know that x minus 2 or x is equal to 2 is a factor. So our new expression is going to be f of x is equal to x minus 2 times 3x squared minus 2x minus 5. Okay? Are we done factoring yet? No. Now we have to factor the trinomial 3x squared minus 2x minus 5. Okay? And what method are we going to use to factor that trinomial? We're going to use sum and product. So we're going to name this g of x, just so we don't get confused. So we have g of x is equal to 3x squared minus 2x minus 5. So what would our product be and what's our sum? Let's start with the easy one. What's the sum? What's the middle coefficient? Negative 2. And what is our product? Oh, remember it's a times c, right? So negative 15. Okay. So what two numbers give us, when multiplied together, give us negative 15 and add up to negative 2?
5, 3.
Perfect. So how did they teach you how to factor using sum and product? Because I know some people use different ways. They use that like cross method, and some of them use the grouping method. Which one did you guys use?
We learned both, right?
Learn both? Oh, I'm used to the grouping one, so I'm going to use that. The crossing method, I myself, I don't know how. I still find it confusing up to this day, but I'm going to stick with the grouping method. But I'll end up probably learning what it means throughout my years of teaching. So you have 3x squared plus 3x minus 5x minus 5. So when we factor by grouping, we're just taking a look at two sets at a time. So which set are we going to take a look at first? The first one, so we're going to take a look at 3x squared plus 3x. So between 3x squared and 3x, what can we factor out from that? We're going to factor out 3x. So we get 3x, and we're left with x plus 1. And then from negative 5x and negative 5, what can we factor out? 5, negative 5. So we're left with x plus 1 on the inside. So our two factors are 3x minus 5 and x plus 1. Okay? So now we know what the factors of g of x are. So now our total equation in factored form is going to be this. So you have f of x is equal to x minus 2 times 3x minus 5 times x plus 1. But although we factored it all out already, what's the last thing we have to do for that question? We're going to have to graph it out. Okay, so first we have to state the characteristics. What is the degree of this polynomial function? 3. Is our leading coefficient going to be positive or negative? Positive. What quadrants is it going to go from and to?
3 to 1.
3 to 1. What are our roots?
2.
Mm-hmm.
5 over 3.
Yep.
And negative 1.
And negative 1. And last but not least, looking at the equation in standard form, what is our y-intercept? Remember, we had the last number in the standard form equation. It was 9 plus 1. What was it? Positive 10, right? So positive 10. So we learned how to graph yesterday. So what are the first things that we need to plot out in our graph before we direct our x-intercept? So we have one at 2. We have one at -1. We have one at 5/3, which is about 1.6. And what else are we going to graph? Our y-intercept, which is 10. So remember, we're going from Q3 to Q1. So because this is just a sketch, you don't have to make it as accurate as you would normally do if I were to tell you to make it accurate. So all we're doing is that we're going starting from Q3 and we're going to end up in Q1. Okay, remember how many turning points is a graph with a degree of 3 going to have? 2, because n minus 1. So that would be your rough sketch for this function in factored form. So this can be a mixture of a thinking/communication question, okay? Only because you have to find k, and because you're going to communicate with me as to how you're going to draw this graph out, okay? So is everyone good with this question? Everyone understand? All right, so now we're going to move on to the actual lesson. So we're going to be factoring polynomials again, except we're going to be learning about the remainder theorem. So what do you guys think the remainder theorem suggests? Remember, if a remainder is 0, what does that mean for that specific number in our polynomial equation? That it is a factor, that it's not a factor. If the remainder is 0,
It's a factor.
it's a factor. If the remainder is not 0, it just means it's just a random point on the graph. So the remainder theorem, so when a polynomial f of x is divided by qx minus p, the remainder is equal to f of p over q. If the remainder is 0, then qx minus p is a factor of the polynomial. So, for example, we have x cubed minus 3x squared plus 4x plus 1 divided by 2x plus 7. So when we isolate for x in the bracket, we are going to get p over q, which is just -7/2, because when we move this 7 over, it's just going to become a negative number. And then if x plus 7, if 2x plus 7 is a factor, so if -7/2 is a factor, and you sub it in for x, that whole equation should equal 0. If it doesn't, then it's not a factor, and it's just a random point in the graph. So for example 1, we want to determine the remainder in each of the following using the remainder theorem. And what can we conclude about the divisor? Okay, so we have 4x5 minus x squared plus x plus 1 divided by 2x minus 1. Okay, so we have our divisor as 2x minus 1 and our dividend as the expression on the left. So what is our factor here that they want us to look at? Okay. And if we were to isolate for x, what would our factor be? 1/2. Okay. So with that said, what are we going to do with x is equal to 1/2? What are we going to sub it into?
Quadratic division.
You can, or the easier way to be would just to take 1/2 and just sub it in for x. So we're going to be looking at f at 1/2. So you have 4x5 minus x squared plus x plus 1. So now we have to determine if 4 times 1/2 to the 5 minus 1/2 squared plus 1/2 plus 1 is equal to 0. Okay. Can we simplify anything?
Yeah.
Okay, what does 4/32 simplify into?
1/8.
1/8. So we're left with 1/8 minus 1/4 plus 1/2 plus 1. What would our lowest common denominator be for that
8.
set of numbers? 8. So we have 1/8 minus 2/8 plus 4/8 plus 8/8. And when you add all of those numbers together, what would our final answer be? 11/8. So is 2x minus 1 a factor of the dividend? No, because 11/8 does not equal 0. Therefore, 2x minus 1 is not a factor. Which means that 1/2 is just a point on the graph. So your point would be 1/2 and 11/8. So does it seem pretty easy so far? Just have to check if it doesn't equal 0 or equals 0. So remember, you guys have a quiz on Thursday. It's just from 2.1 to 2.4. Okay, just the first 4 lessons. And your assignment, I think it'll probably be on Tuesday. Like I said, everything's probably going to be online. Okay, so it'll probably be due Tuesday at like before midnight or something like that. So remember, the assignment is your application and thinking part of your mark. So it's all the written work that you're going to be doing. So now that we know that 2x minus 1 isn't a factor, we're going to go on to our next example. So we have x cubed plus 7x squared plus 14x plus 8 divided by x plus 2. So if we were to isolate x plus 2, what would our factor be? X is equal to -2. So like question A, what are we going to do with that -2? We're going to sub it in for our dividend. So we're going to find f at -2 is equal to -2 to the power of 3 plus 7 times -2 squared plus 14 times -2 plus 8. So what's -2 to the power of 3? -8. What's 7 times -2 squared?
28.
28. Minus 28 plus 8. And when we simplify those numbers together, what is the result? 0. So if it gives us 0, what does that mean about x plus 2?
Factor.
Therefore, x plus 2 is a factor because it is an x-intercept. I mean, Matthew, you could use synthetic division like you said. It'll just give you 0 at the end. This is just easier because you're just plugging in the number and you're just figuring out if it's 0 or not 0. So is everyone good with remainder theorem so far? Okay. You guys, I'm saving these on my USB, the filled out stuff. Do you guys want me to post that too or not really? Yes, no? Or is the recording good enough?
Yeah.
Recording. Okay, so we're going to move on to example 2. So if x plus 1 is a factor of x cubed plus x squared plus kx plus 2, what is the value of k? So what are we gonna, how would we approach this question?
That equation equals 0.
Okay, so we're gonna make this whole equation equal to 0. So you have 0 is equal to x cubed plus x squared plus kx plus 1. But since the question states that x plus 1 is a factor, what are we going to sub in for x? -1. Okay, so now all we have to do is just simplify all the exponents. So -1 to the power of 3, what does that give us? -1 plus 1 minus k plus 2. So now if we take the like terms, what does it simplify into?
Is equal to 2.
Okay, so you have 0 is equal to 2 minus k, which means if we move k over, k is equal to 2. Therefore, the dividend, or f of x, is equal to x cubed plus x squared plus 2x plus 2. So we learned about the remainder theorem. Now we're going to learn about the factor theorem. Okay. So the remainder theorem is just to check if our equation at that factor is or is not equal to 0. Okay, but the factor theorem is something different. So the factor theorem is used to factor polynomials that cannot be factored by any other methods. So the factor theorem is a special case of the remainder theorem. So x minus p is a factor of f of x if and only if f of p is equal to 0. Or in this case, q of x minus p is a factor of f of x if and only if f of p over q is equal to 0. So what it means by p and q is we're basically taking factors from our constant value and factors from our constant value at the highest degree that's in front of it. I'll explain what that means in the next example. So how do we know which values of p or p over q should we try so that f of p is equal to 0 or that f of p over q is equal to 0? Okay. So all we're doing, so this is our p, and this would be our q. Okay. So all we're doing is we're taking factors of p and factors of q and trying to figure out which one is a factor of the polynomial. So all we're doing for example 3 is we're just looking at factors of p and factors of q. What are the factors of 5, of negative 5 at least?
Yeah, 5 and 1.
Okay. What are the factors of q, which is 2?
2 and 1 or negative 2.
Okay. And then what if we have p over q? What does that include? So what's 1 over 1? So we're just going to get 1. Positive negative 5 over positive negative 1 is just positive 5. And then we get 1 over 1, which is 1. And then we get 1 over 2. And then plus or minus 5 over 2. So the possible factors of 2x squared plus 9x minus 5 can be positive and negative 1, positive negative 5, positive or negative 1 over 2, positive or negative 5 over 2, and that's pretty much it, okay? So one of these, if you sub it into 2x squared plus 9x minus 5, is going to give you 0, okay? One of those is going to be a factor. When I was doing this in high school, some of my students were like, sir, how do you like just pick out a random which one works? Honestly, start with the factors of p, because that will usually, most of the time, end up being a factor of the polynomial function. So if you were to try to figure out which one of these numbers is probably going to give you 0, try positive negative 1 or positive negative 5. So the factors of p, I would try first, because that is usually the case. These fractions happen a handful of times, okay? But the thing with the factor theorem is that I find it tedious because when you get up to this point, you're basically just doing trial and error to find which one of them give you 0, right? Which is the reason why the remainder theorem is probably the best one. But if you don't have a factor, if it doesn't give you a factor, you're going to have to do the factor theorem. So remember, negative 8 is our p, and 1 is q. So what are the factors of 8?
4 and 2.
1.
And 1.
Yep.
2, 4, 8.
Mm-hmm. And last but not least, what is a factor of 1? This one. So if we do P over Q, what is it? Does it just give us back? Not one, but it gives us back all the elements in P, right? It throws us back the set of P, which is positive -1, positive -2, positive and -4, and positive or negative 8. And then example C, we have 2x cubed minus 8x squared plus 5x minus 6. So what are my factors of 6? 1, 2, 3, 6. And Q, we just have positive -1 and positive and -2. So what does P over Q give us? All of P plus what else?
1/2. 3/2.
And 1/2, right?
We have to write all of it. Can I say like E, comma, and then the rest?
You can do that. I wouldn't mind that. So what Adam was saying is you can write P over Q as an element of P, and then comma, just write the last two factors from P over Q. So now we're going to go into some questions that involve using the factor theorem. So we want to factor each of the following expressions. So the first one we have is 2x to the 3 minus 2x squared minus 3x plus 3. So before we use factor theorem, is there any other way that we can factor this? Which two are we going to group together?
First two. No,
Okay, so we're going to group 2x cubed minus 2x squared and minus 3x plus 3. So from 2x cubed and 2x squared, what can we factor?
2x squared.
So we're going to factor out 2x squared. So we have x minus 1. And from negative 3x and positive 3, what can we factor out? We're going to factor out a negative 3. So we get negative 3, and we're left with x minus 1, which means in factored form, this is 2x. We have x minus 1 times 2x squared minus 3. Can we somehow factor this if we move something over? What can we move over? 3. 2x squared is equal to 3. And then what can we divide both sides by? 2. So we get x squared is equal to 3 over 2. And then square root. So we get x is equal to plus or minus the square root of 3 over 2. So here we have x is equal to the square root of 3 over 2, or x is equal to negative square root 3 over 2. So are we fully done now?
Yeah.
The only reason why A worked by factor by grouping is because when we factored by grouping, both brackets gave us back x minus 1. If they were to give us back different binomials, would it work in that case? No. So for factoring by grouping, the two brackets have to give you back the same expression. So example B, we have x cubed minus 4x squared plus x plus 6. So how do you think we're going to factor or try to factor this expression? What theorem are we going to use? Remainder theorem or factor theorem?
Factor.
We're going to have to use factor because for the remainder theorem, we would need to have a factor already. So this is where the annoying part comes. So we have to list all the factors of P. So what are all the factors of 6?
1, 2, 3, 4.
Yep. And then Q is just positive and negative 1. Which means that P over Q just gives you back P. So now what we have to do is we have to pick one of the factors, 1, 2, 3, or 6, sub it into the polynomial expression, and hopefully it gives us back 0. So which one do you guys want to try with first?
3.
You want to try 3? So we're going to sub 3 for f of x. So f of x, f of 3 is equal to 3 to the power of 3 minus 4 times 3 to the power of 2 plus 3 plus 6.
Would it be either positive or negative 3 that you could pick?
You can pick either or. So if you want to pick negative 3, we could have done negative 3. So when we simplify all of that, f of 3 gives us what?
0.
Okay, so we have 3 to the 3 is 27 minus 936 plus 3 plus 6, which gives us 36 minus 36, which gives us 0. Okay, so that means 3 is a factor of x3 minus 4x squared plus x plus 6. But they want us to fully factor the whole polynomial expression. So what would be our next step into factoring that whole polynomial expression. So we know f of 3 is a factor. So what would our next step be? What type of division do we want to use? We're going to use synthetic. So we have 3 here. We have 1, minus 4, 1, and 6. So we're going to drop the 1 right away like usual. So 1 times 3 gives us 3. Negative 4 plus 3 gives us negative 1. Negative 1 times 3 gives us negative 3. 1 plus negative 3 gives us negative 2. And what's 6 plus negative 6? 0. So what we're left with is f of x is equal to x minus 3 times x squared minus x minus 2. So how can we factor that last trinomial x squared minus x minus 2? Sum and product, okay? What gives us a product of negative 2 and the sum of negative 1? Negative 2 and 1. So we get x minus 3 times x minus 2 times x plus 1. So that would be our polynomial expression in factored form. And once we have that, it becomes pretty much easy to graph. It's a degree of 3. The leading coefficient is positive, so it goes from quadrant 3 to quadrant 1. And obviously, because it's all factored, we have our zeros given. So if you were to go back to the factor theorem, Matthew used positive 3. If you picked positive 2 or negative 1, it would have worked as well. And based off of that, what numbers wouldn't have worked? 6.
Negative 3, negative 2.
And positive 1. So yeah. So like I said, if you end up picking the wrong number off the bat and it gives you a remainder, you're going to have to pick another one and do it again. All right? So did everyone understand that example? Everyone's good? So the next example we have is 2x cubed plus 3x squared minus 11x minus 6. So again, we're going to have to use our factor theorem. So we need the elements of P and Q. So factors of 6 we found to be 1, 2, 3, and 6. And factors of Q we found to be positive, negative 1, positive, and negative 2. And P over Q, we have all the elements in P plus 1/2 and 3 over 2. So now for the factor theorem, we have to pick either factors from P or a factor from P over Q and sub it into the expression, and it should give us 0. So what number do you guys want to try out first?
2.
Okay, let's try out 2. So f at 2 is equal to 2 times 2 cubed plus 3 times 2 squared minus 11 times 2 minus 6. So 2 times 2 cubed gives us what? 16. What's 3 times 2 squared? 12 minus 22 minus 6. So when we add and subtract all of those numbers together, what does it give us? 0. Which means 2 is a factor. So now what we have to do next is synthetic division, like we did in the second question. Right? So we get 2 times 2 gives us 4. Then we add those two numbers together. We get 3 plus 4, which gives us 7. 7 times 2 is 14. Negative 11 plus 14 gives us positive 3. 3 times 2 gives us 6. And as you can see, our remainder gives us 0. So now we're left with f of x is equal to x minus 2 times 2x squared plus 7x plus 3. So now all that's left to do is we need to factor the 2x squared plus 7x plus 3. So what would our sum be? 7 and our product?
6.
What two numbers give us multiply the negative to positive 6 and add up to 7? 6 and 1. So we got 2x squared plus 6x plus x plus 3. So factor by grouping again. So what can we factor out from 2x squared and 6x? 2x. And then plus basically 1, and then we're just left with x plus 3. So our final answer in factored form is f of x is equal to x minus 2 times x plus 3 times 2x plus 1. You guys have any questions so far about factor and remainder theorem? Right. All right, so we have 4 more examples, and then that's pretty much the lesson. Then I'll probably get you guys to do the mid-chapter review for Unit 2. This should take us up until the break and a bit after. So we have 4x to the power of 4 minus 6x cubed minus 6x squared minus 4x. So before we get into factor theorem, what can we factor from that whole expression?
2 Yeah.
2x. We're left with 2x3 plus 3x squared minus 3x minus 2. So now we have to take our factors from P and Q.
Can't you group this one?
Good idea. So what do you want to group?
First two.
First two?
First
So
and
the first and the last? Oh, just to factor out the two? Because you need the, remember the brackets have to give you back the same thing. Right? So if we were to group 2x cubed minus 2 and 3x squared minus 3x, if we were to factor those, would the brackets on the inside be the same? No. So then it would not be possible. But if they did give you back the same bracket, you would be able to factor by grouping. So we have our factors of P, which is plus minus 1, plus and minus 2. The factors of Q, which is plus minus 1, plus minus 2. And P over Q, which just gives you back P. And plus and minus 1 over 2. So we need to pick either a factor from P or a factor from P over Q. That when you sub it in to the polynomial expression, it gives us 0. So we're just going to worry about the inside. Because if this is 0, then it doesn't matter what 2x is. Does anybody want to shout out a number to try?
2.
You want to try 2?
1.
So let's try f at 2. So 2 times 2 to the power of 3 gives us 16. Plus 3 times 2 squared gives us 12. Minus 6 minus 2. Does that give us 0? No.
Can you plug it into the original equation, or do you have to do it into the factor?
You can plug it into the original. Half of the time, it's the easiest number that you can think of. So let's try f at 1. So we have f at 1 is equal to 2 times 1 cubed plus 3 times 1 squared minus 3 times 1 minus 2. So you have 2 plus 3 minus 3 minus 2. And when we add those and subtract them together, what does it give us? 0. So that means at x is equal to 1 is a factor. So the only problem with these things and factor theorem is that they can become long depending on the expression you have. So some might take just 2 steps, others might take more than 2 steps. But I'll try to keep it generally not too long. Okay, so I'm not going to give you like a polynomial with 10 things in it because that's just going to take forever. So we have 1. We're going to use synthetic division. So we have 2, 3, -3, and -2. So for synthetic division, I'm just using what we have inside of the bracket. So that expression. So like usual, we drop down the first number. So we have 2. 2 times 1 is 2. And then we keep adding and multiplying. So we get 5. And we get +2 and 2. They cross out. And it gives us 0. So what we're left with is f of x is equal to x minus 1 times 2x squared minus 5x plus 2. So now again, like the previous examples, we need to use a sum and product to factor the trinomial 2x squared minus 5x plus 2. So our sum is -5. Our product is +4. So what would the two numbers be? 1, -4, -1, right? So we're going to factor by grouping. So the first one, we're going to have to factor out. What can we factor out from 2x squared and 4x? 2x. And then a -1 out here. So then we get x minus 2. And when we factor everything together, we get x minus 1 times 2x minus 1 times x minus 2.
For that too, can you use the original equation or no?
Which one?
Like can you use the original equation to do synthetic division?
For this too?
No, like
Oh, like in general?
Like the numbers, the 2, 3, -3, and 2. Could you use 4, 6, -6, and -4?
You can. It would still work. But it would just add an extra step because you don't have that coefficient at the end. So our final answer is f of x is equal to x minus 1 times 2x minus 1 times x minus 2. Oh, then I'll just give you I'll just assign you guys one of the quizzes I gave my grade 12s from last year as your. Oh, I messed up. It's supposed to be a plus 5x. Whoops. If you guys ever notice that, just let me know. Right? Doesn't completely change the answer, but it just makes these things positive. And what am I forgetting in my final answer? What was the first thing we did with this question? Yeah. So I already talked with cohort B about it. If you guys see me make mistakes, my ego's not going to get hurt. Okay, just tell me. But from our discussion on Friday. They're like, I don't like telling the teacher if they're wrong, because if I'm wrong, then it just looks stupid in class. So if I'm ever wrong, just tell me, and I will just look at it. And then if I'm wrong, I'm wrong. I'm not a perfect math teacher, okay? I like to say I'm a pretty decent one, but I do end up making mistakes. Sometimes you'll hear me say the answer while I'm asking a question. So for example, if I'm doing 2 times 6, I'll say, what's 2 times 12? Because I already have the answer in my head, so I'll accidentally say 12. And I just mean to say 2 times 6. So is everyone good with this question? Or is it a lot of steps? It's good? Based off what Mrs. Brisenden has done, we're pretty much both on the same lesson and same unit so far. So none of us is ahead of the other. So our last example for factor theorem before we get into some thinking and application questions, we have x to the 4 minus 3x cubed minus 13x squared plus 3x plus 12. This one's going to be longer than the last one. Okay. So again, you have to take factors of p and q. Because q is just 1, we're just going to ignore the factors of q because it's just going to be plus minus 1. So it's really redundant just to write that down because p over q is just going to give you back p. So what are the factors of 12?
1, 2, 3, 4, 6, and 12.
Yep. So now we have to pick, you have a 1 in 12 shots of getting the whole thing equal to 0. I mean, in terms of probability, that's a pretty low chance of getting it on the first try. But like I said, it's usually one of the easier numbers. 1. So let's try f at 1. So you got 1 to the 4 minus 3 times 1 to the 3 minus 13 times 1 to the 2 plus 3 times 1 plus 12. So we got 1 minus 3 minus 13 plus 3 plus 12. So does that give 0?
Yeah.
Yeah. Because we essentially get 15 minus 15. So f of 1 is equal to 0, which means x minus 1 is a factor. So we're left with f of x is equal to x minus 1 times, we need to figure that out by using synthetic division. This is what you call a multi-step question. So, like usual, we bring the first number down. So we got 1. 1 times 1 gives us 1. Negative 3 plus 1 gives us negative 2. And you keep doing the same thing, add and multiply. So what we're left with in the bracket is x cubed minus 2x squared minus 15x minus 12. So unfortunately, what do we have to do again? We're gonna have to do the factor theorem again. So factors of p, we already did 12, so we have plus and minus 1, 2, 3, 4, 6, and 12. So now looking at this polynomial expression, and given the factors of 12, which factor do you think will give us 0?
1.
You want to try 1 again? So if we plug in 1, we get 1 minus 2, which is negative 3, minus 15, which is negative 18, minus 12, which is negative 30. So does that give us 0? No. What other one do you think you're going to try? Negative 1. Okay. So we got negative 1, minus 2, plus 15, minus 12. And when we simplify that, that gives us an answer of 0. Which means f at negative 1 is equal to 0. So we are left with f of x is equal to x minus 1 times x plus 1. And then we need to figure out what our remaining trinomial is. So remember, we're still focusing only on the polynomial expression in the bracket. So we have 1, minus 2, minus 15, and minus 12. So what's the first thing we always do is we drop down our 1 first, for the first term. And then all you do is multiply. So negative 1, zero. So our trinomial is x squared minus 3x minus 12. Is it possible to factor that trinomial? No. What technically could we use to factor it? Quadratic formula, okay? So when we do b squared minus 4ac, okay, which is the discriminant in the quadratic formula, it gives us 57. Does 57 have a perfect square root? No. Okay. So you would be able to use quadratic formula. If I were to ask you to graph it, then you would use it. But because I'm just telling you to fully factor it, this is the most it can go, because you can't really factor that with whole numbers. Okay. So only use the quadratic formula if I'm asking you to sketch the graph of it. But if I'm just asking you to factor fully and you can't factor using sum and product, just leave it like that. All right, so you guys are going to take a break now, and then we have 2 more examples after the break, and then you guys can do, I'm going to put up the extra homework for the unit, so that you guys can work on after I'm done this lesson.